Okay, hi. So, woo, yay. A few weeks ago I was in Singapore. This is a photo of my bike in Singapore. Singapore is it is a really green city. It is absolutely amazing, and was there at Conf Singapore. If you get a chance to go over there next year, 2021, do so. Great conference, great bunch of people. The call for proposals is already open. It is going until after Dub, which is a very good thing because Dub changes the world. And yeah, I encourage you all to attend iOS Conf Singapore here. But that's enough of that. So, I am going to be talking about SwiftUI and SVG. And this happens to be a love story, which is really nice. It's cool, it's awesome. So, let's have what this story is. So, we are going to talk a little bit about who the parents of the couple are, because parents matter. We're going to talk about who the couple are. So, SwiftUI and SVG, we're going to talk about how they met, and we're going to talk about their relationship. All that in 20 minutes. I had 35 minutes at Singapore, so we'll see how this goes. Parents of the couple. So as we all know, we need to know who came before, who this couple has come from, and what they're all about. And thanks for the tweets, I get them all on my watch. Melbourne CocoaHeads, yay! First, let's talk about raster images. So there are two main types of images as far as how you draw them, how you understand them. One of them is raster. So raster is your bitmaps. That is different bits of information across the screen. I am going to absolutely butcher this explanation for the sake of time, and other people could do it much better than me, but raster is you are drawing by saying the information here is one color, the next different color, and so on to make up your image. So it is drawing an image by providing the absolute information of how an image should be. The next type of image is a vector image, and what this is saying, okay, we know that this particular thing here is a square, and we will draw it as a square, and we will say, well, why don't we fill it, say, pink or red or green or purple, and we'll give it a border, we'll give it some rounded corners and stuff like that. So instead of going pixel, we are being a bit more declarative about our information about how we are drawing the image. And as we all know, being declarative about things is good, because that's what SwiftUI is all about. It is dealing with large image sizes. So as we all know, when we are dealing with mobile devices, when we are dealing with desktops, when we are dealing with the web, images can become very, very large. Now, most people, when they take a photo on a phone, it's going to be about 12 megapixels or around about that. If it's on a DSLR, it can be a lot larger. So we are dealing with situations in mobile app development and desktop app development and even website development where we go, hey, here's this ridiculously large image, let's present it on the screen. So this is one of the issues we are having to deal with. Another situation we are having to deal with is different screen sizes. So for a long time, iOS was only a single screen size. And then it went to a larger screen size with with the iPhone 4 and Retina. And then after that, when the iPhone 6 came out, we had the 6 and the 6 Plus. And then when the iPhone 10 came out, we had even more sizes. 10s Plus brought even more sizes, and I'd hate to say it, but we're just going to keep growing and growing and growing. We're not Android, which has dealt with this thing for a long, long time and already has SVG. We are now, as a community, really starting to grapple with all of this. So we need a way to deal with all of these different image sizes. If we're dealing with raster image, then we are going to have to stretch and manipulate and try and distort or compress images. Whereas if we're dealing with a vector image, we just go, hey thing, scale yourself. Cool, okay. The thing we're going to talk about is who the couple are. So the couple is SwiftUI, and we are going to talk about SVG as well. So SwiftUI is the new boy on the block. As I said, this is a love story. So new kid coming onto the scene is trying to understand where does he sit, where does he fit in this whole situation. So the thing about SwiftUI is he's all declarative. That is, he's not being the one going, hey, I'll do this thing, this thing, this thing, this thing, this thing, and eventually myself will change. More going, okay, this thing has happened, I'll become a new person as a result and keep going on like that. So that's pretty cool. The other thing is SwiftUI is all about immutability. That is, if you try and change who SwiftUI is, you won't actually get a modified or updated version. You will in fact get a new version. So what you're dealing with is a new instance of SwiftUI. That's pretty cool. Now we get to the boy we have always known, and that is SVG. So SVG has been around for a very, 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 very long time. Anyone that has done web development for pretty much since the 80s has likely come across SVG, because that's around the 2000 is the time that SVG was defined and brought into an actual standard. So it went through the W3G, which is the World Wide Web Consortium. It went through the working groups, got ratified, stuff like that. So around that time is when SVG was defined and has been around for a long time. Now, SVG is all about vector graphics. That is, it's not about going, hey, first pixel you're red, next pixel you're green, blue, whatever. It is all about defining an image by going, hey, here's a square, a circle, a path, an ellipse, a rectangle, a group of things being transformed. This is how vector graphics are defined. Now, everyone these days is always going, hey, let's define things in JSON. SVG is XML. Now, XML it has a bad reputation in, you know where I'm going with this. XML has a bad reputation in software development circles because it is not hip, it is not cool, it can sometimes be slow to pass. But the thing about XML is it has types, it has definitions, it has everything we really, really love as developers who use Swift and who love functional programming, we actually like the fact that things are defined, things can only be particular type or something like that. So being XML is good. Long live XML. XML much better than JSON. I said it. It's all good. Okay. Let's talk about how the two met. So we've got these two boys and they are very similar, but they know nothing about each other. So how do they meet? How do they get to understand each other? And the main thing that draws them together is a passion for understanding. So they each want to know more about them. They each want to know who the other is and what they're all on about. There's also mutual cooperation because you've got two particular boys that are all about drawing from a vector or a well-defined situation, so they're after the same thing. Now, in any good love story, there is always the competition. There are the people that are out for particular bits of affection and stuff like that. In this particular case with SVG, there are other alternatives to SVG that you can use within SwiftUI. One of them is IJSVG, which is from IconJar. Now, this is a very well-behaved SVG implementation. It is one that meets the standards to a large degree. It is all written in Objective-C. No. And it actually uses manual reference counting. You're cool with manual reference counting, oh. Okay, so for the benefit of the people on the live stream, there was a bit of back and forth and banter about manual reference counting, and there happened to be the remark of, said the man who likes XML. Yeah, point. So IJSVG, it is a mouthful, a tongue twister, but it is actually a really, really good implementation of the SVG standard. And if you're doing an app kit, now this is an app kit library, as in is targeting Mac OS, not iOS. If that is what you're after, it is suitable. It does everything on the background, it does exporting and a whole heap of stuff, so it's good. Another option is, why not just use PDFs? Like, everyone knows PDFs, you can export to PDF. UI image supports PDF, so why not use it? Yeah, no, it's slow. And the other option is, well, if the web is what's supporting and driving this, why not just do it in a web page and use WebKit? And then you have this situation where you go, well, I've got a collection view, and this collection view has, say, 10,000 items, and all of these items are like 50 by 50 pixels. So how many instances of WK Web View is that? It's a lot. So again, there are many different solutions to this. These are appropriate in some situations. I don't think they're appropriate in this situation. Okay, fun stuff. Let's talk about their relationship. So talk about how the two understand each other, get to know each other, and are able to present images in a device or in a macOS. So let's first get to know SVG a lot better, the old boy on the block. Let's see what he's all about. Now, as I said before, SVG is all about XML. Everything in XML is a tree structure. So you always hear these bad stories about going, hey, reverse this by tree, or in an interview and everyone complains. This stuff actually has a purpose. It is just very limited and should never be in an interview because you can always Google it and come up with a better solution. XML uses a lot of attributes. So you will say, this node is a circle. And with that circle, we have, hey, your center point, your center X and Y, your CX, CY attributes are 10 and 10, just as arbitrary numbers. And that's how you sort of start to define things, particularly with your attributes. There's no body content in an SVG file other than other SVG nodes. So like a group, and then within that group you'll have rectangles, lines, paths, stuff like that. But all of the information around those is defined in the attributes, not the body content. That's cool. Path commands. So path commands are this really horrible to pass string of what could appear the arbitrary values, but say, hey, draw a line from one point to another, move to another point, do an elliptical arc, and stuff like that. So that's a basic overview. Let's have a look at what something like that is. Hope you can all see it. Yeah. So what do we have here? We have a rectangle and a couple of ellipses. This is pretty cool. So we have at the outside the SVG element defining its width and its bounds, and have a border being drawn. And in that border we have a couple of ellipses. Pretty cool. This is all it takes for two ellipses and a rectangle on a screen. It's parsing. So, yeah, sorry, that's horrible. Yeah, what we have here is, as I said before, everything is a node. So when you're parsing a XML element, you can kind of cheat in that you end up creating a node which is in concrete type, and then define the attributes in that. And then you define its children, its children, its children, its children, and so on. And this is pretty cool in that all you need to do in order to parse this XML structure is just do so in a recursive fashion, and it all works, and it works pretty well. I am glossing over a lot of information. All of this is up on GitHub, and I'll mention it at the end. As I said, everything is a node. For those who know me, I like clean code. I like code that is contained and well-defined. Unfortunately, at the moment, this particular class definition is over 500 lines. Sorry, but there is a lot going on, and there is a lot to take care of and think through. Okay, moving on. Attributes. The attributes of XML. We've got stuff like defining the width and the height. We've got defining the origin point. So the origin point is typically the top left corner, and we can define that like as 1x, y1, and that. We can also have particular elements like ellipse and circle, which define their reference from a center point. So in that case, you have cx, cy. If you're defining a circle, it has a single radius point. Defining an ellipse, you have 2 radius points, and so on like that. The XML standard is fairly involved, and yeah, I recommend people looking at it, trying to understand it, because it gives a good idea of how it is things are drawn on your device. Path commands. Now, path commands are where things get really, really, really interesting. So you've got a whole heap of different commands that are defined by single character values. These are up here. So we've got stuff like M and M, L and L, H and H. So you'll always find that a character has an uppercase and a lowercase variant. The uppercase variant is always these points and values are absolute, whereas the lowercase is these are relative to the last coordinate. So by these commands, you can do things like move from one point to another, draw a horizontal line, a vertical line, a straight line, a quadratic curve, a elliptical curve, a arc, and a whole heap of other things that make it really, really good. So this is all who XML is. Now we're moving on to something like SVG. So, SVG. And this is more just trying to explain the different types of commands and how they relate to each other. So what I have here is the representation of just moving from a few points and drawing some lines. Again, lines both arbitrary, horizontal and vertical, and using absolute and relative points. Then you get to things like Bezier curves, which can be fun to try and implement. You have things like an arc, which again have their own difficulties, mainly in how the representation is. If you were to look at that as just a straight series of numbers, you would be interpreting it incorrectly. The reason behind this is some of the values, like when it's 1 and 0, so can make this out, but at the top, you've got like A, 6, 4, 10, 1, 0, 14, 10. The 1 there, not values 1 and 0, they're actually true. And SVG and the commands in particular don't clearly define that there are spaces or usual delineation between those. So you could, for instance, have 1, 0, 1.23, and that should be interpreted as true, false, 1.23. And in that case, this is why most SVG parsing is different based on what library, what web browser you use, because of stuff like this. Fun fact. And then you have something like Z, very simple. This is just saying, hey, go from your current position to your starting position, close the path, and you're done. Parsing this stuff. So, as mentioned, the path commands can be very involved, they can be very complex. There's often a lot of stuff going there. If you, say, have multiple coordinates after a line, then it means different things like move and then draw multiple lines and stuff like that. So what we need to do is use a scanner, an NS scanner, to just grab all of those coordinates and make sense of them. Again, understanding command. This is stripping out the value like A or M or L or A and making sure we have that as a single value that we can then say this is a horizontal line, a vertical line, or something like that. Okay. We've got an understanding of who SVG is. Okay. Now let's try and understand who SwiftUI is and look at the relationship between SwiftUI and how SwiftUI helps us understand SVG. Now with SwiftUI, we again have a series of very basic building blocks that allow us to do our drawing. Start rectangle, circle, ellipse, shape. All of these have been around in for a long, long time, but they have a bit more prominence in SwiftUI because SwiftUI encourages you to draw things a bit more manually and do animations and stuff like that, which is pretty cool. So let's now look at how we can take the information in SVG and show using SwiftUI. First one is a rectangle. What we're doing here is we are creating a Z-stack, which is an arbitrary canvas. In that, we are drawing two rectangles. These rectangles are for the border or the stroke of the and then a second one for the fill. We're then offsetting it by the required amount. So with the rectangle, we get X and Y as attributes, and that's the offset from 0, 0 to the point where we want to start drawing. Again, we also get a width and a height that we can then use to draw this element. Similarly, with circle, we have our outside circle, which is our stroke, and our inside circle, which is the fill. But this time we are doing a position, which is we are moving the middle point, so the point right in the center of that circle, to the required value, which is specified in the CX and the CY attributes. Ellipse, very much the same, but in this particular case, we have multiple radii that we need to draw from, and we're then translating it and setting its size accordingly. Shape is where it starts to get a bit more interesting, in that a shape is very much a Bezier path from UIKit and from AppKit. And this is what is allowing us to do a lot more of the complex details in an SVG graphic. So when we get a series of path commands, what we are doing, we are translating it from the XML into a Bezier path. Again, this is more of how that works. Now, when we are drawing an SVG as a whole, we then have sort of our final transformations and sizing and scaling and stuff like that. So we've got our container, and then we can do stuff like, we were originally here, but what happens if we draw it over here and then we rotate it and we scale it down? So stuff like that we can do very easily, and that's by applying a series of affine transforms. By using a drawing group, what we are doing there is we are saying, hey, this on the main thread, do it on a background thread instead. Now, all of this happens with SVG because it's a tree-based structure. We need to handle things recursively. So when we call draw, we are recursively calling a function that looks very similar like to this. And we're going, okay, give us a bit of a canvas and then start drawing elements in here. What might not be completely obvious for us is we have all of these sort of rect 4, circle 4, ellipse 4 and all that are returning optionals. So if our particular element doesn't match, we just draw nothing until we draw something. All works pretty cool, and we then sort of apply the transforms and stuff like that. Cool, okay. That's the basic drawing. Now let's look at something a bit more complex. Let's look at our path commands. Again, all this is recursion. So with an element, you have a single path attribute, and that path attribute has a series of commands that you need to recursively wander through. If we're wanting to do something like move, what we are doing is we're just going, hey, get the coordinates, make a point, and then move to that point. Again, with the line, we have the absolute and the relative versions of it. And we are saying, hey, you're drawing a line and stuff like that. If it's the relative one, we want to grab the current point, which is an optional. That's pretty cool. Horizontal lines, vertical lines, much of the same. We're just using line 2 in that regard. This is where things get a bit interesting, in that we have a whole lot of stuff around drawing Bezier curves, cubic curves, arcs and stuff like that. And this requires putting in goal points and a few other interesting things. Cool, okay. That is who SwiftUI is and how he is trying to get us to understand SVG. Now, that's all good, but as I said, this is a love story. So, as with any good love story, they have a plan to elope, and their plan has resulted in it all being available on GitHub. You can check out this code and understand a bit more about it as well. All love stories have multiple people involved. So make sure that stuff like Mozilla, the W3C, and Apple get the thanks they do. Also, all of you, you're awesome. Thanks for listening to the talk. And that is all I have.